Hi everyone. In this chapter we're going to be looking at systems of linear equations. In this first lesson we're going to be looking at what a system of equations is and how to solve it graphically.
Okay, so let's start with defining a system of equations. Okay, so we read here that a system of equations consists of two or more equations that are considered together. In other words, we're going to assume that they're true simultaneously. Okay, both relationships are equally valid at the same time here. So a linear system of equations is simply going to be a system of equations where each equation represents a straight line. Okay, so a straight line. It's linear. If you want to think of it like this, they're all degree 1. Okay, so here's an example of a linear system. 2x plus y equals 2. X minus 3y is equal to 15. Okay, now down here we read that the solution to a system of equations is the point of intersection, and that's, man, we cannot emphasize that enough. It's the point of intersection between those two lines. And so that when you substitute that back in, the left side equals the right side. Now that's true for both, okay, equations. That the left side equals the right side. Now, it helps to have a quick look at what's going on here graphically. So in order to graph these equations here, what I'm going to do here is first of all, I'm going to label them like this. You're going to see this is a fairly common tool to use for labeling. Okay, we'll label the first equation 1 with a circle around it, 2 with a circle around it here. And then what I'm going to do here is, to get a sense of what's going on here, I want to see what's going on. So I'm going to graph this. And to do that, I'm going to put it in slope-intercept form. So here's equation 1. And what I'll do is I'll bring the 2x over. So I'll get y equals negative 2x plus 2. And now that's in slope-intercept form. And that's easy enough for me to put into the calculator. Equation 2, I got to do a little bit more work, and I'm going to bring the x over. So negative 3y will equal negative x plus 15. Then I'll divide by the negative 3 there, and so I'll get x over 3 minus 5. Okay. Now, I'm going to put this into my calculator, and I've already done that. So I want you to have a quick look at this calculator here. So those are those two equations here. Now I will zoom in a little bit so you can see this. Whoops. Okay. And when I graph that, take a look at this. Okay, so here are my two equations here. Now, when you think about it, the solution of the system is really the point here that kind of jumps out at you. And in that case, it really is just this point of intersection between those two lines. That point right there must be important. And it is, because in this case, what we know here is that particular point satisfies both equations here. Now, we're going to talk about graphing a lot more in this lesson here. We're going to do a lot of that by hand. At this point right now, what we want to do here is I'll show you how to do this on your calculator real quick. When you have plugged the system into the calculator here, to find that point of intersection, if you press second and then trace to get into your calc menu, that gets you into this menu right here. And your options are value, 0, minimum, maximum, and here's the one we want here, intersect. So I'm going to press number 5. And what that does is that opens up this screen right here. We're looking at the graph again, and now you see that the cursor is blinking on the first line here. And the calculator is asking, is this the first curve? Now I'm going to press enter to say yes. Then it immediately jumps to the only other line that's got there, and it's asking, is this the second curve? I press enter to say yes. Now, when the guess here is simply a tool that the calculator uses to help it get to the answer faster. I mean, if you wanted to guess what the answer was for x there, you could, but don't really worry about it. Just press enter to get past the guess. And you see really, really quickly here, it gets us the point 3, negative 4. Now, let's just go and look back at our system here and talk about that. So the point of intersection, okay, our point of intersection here, okay, was the point 3, negative 4. Now, what that meant, okay, or what that means for us right now here, is that that particular point satisfies both equations. Well, let's just take a look at equation 1 here. Okay, and to start off with, our equation was 2x plus y equals 2. Well, let's just take a quick look at that. 2 times 3 plus negative 4. Okay, well, 2 times 3 is 6 plus negative 4. Well, that's 2. Yep, that works. Equation 2, let's look back over here. Equation 2 is x minus 3y equals 15. Let's plug in that point. Okay, 3 minus 3 times negative 4 Well, 3, this is going to be positive 12. 3 plus 12 is 15. Yes, that point satisfies both equations. That's what we mean by this. That's what we mean by the left side equals the right side. Okay? So good. So that's what we mean by a system of equations, if you will. Here, I'm going to zoom back out here so you can see the whole sheet. Okay? Two equations that are true simultaneously. The solution to that system, and remember, a system's got to have more than one equation. The solution is the point of intersection between those two lines, the point that satisfies both of them. Now, one way is to solve these is graphically, and it's a great way. It's an obvious way to solve this. I'll show you how to do the calculator a little bit more as we go through this, but we want to focus on doing it by hand. Okay, so we want you to think back to how you graph these lines here, and so there's a couple of methods that you can use here. To graph a line, you can use kind of either of these methods here. You could use the x and y intercepts. Okay, this is a particularly useful way of doing this because most of these equations are going to be written in standard form. Ax plus by equals c. It becomes really, really easy to get the x-intercepts. I mean, if you want the x-intercept, you cover up the by term, divide by a. If you want the y-intercept, you cover up the ax term, divide by b. I mean, it's a really easy thing to do, and then you can just connect the dots here. I'm not a huge fan of that method, I'll be honest with you guys. It works totally fine here, but you only get the 2 points, then you got to connect them with a straight line here. I prefer the slope-intercept form, okay, because our y-intercept pops out, and that's kind of our starting point when we graph, and then we use the slope to help us get from one point to the next, but they help us really find these lattice points here. For most of the questions you're going to do, it's just going to be a nice, easy way to use the slope to go from lattice point to lattice point, and you will get a lot of them in most of these questions, and that's actually an easier way to graph the line. This method, typically you'll end up highlighting the point of intersection even before you find out that it is the point of intersection, okay? And you'll see me do that in a little bit here. So anyway, that's what we want to get right now. Okay, I want you to keep that in mind here, that a system of equations is two or more equations that are true simultaneously. The solution is the point that satisfies both of them.
Example 1. Graph the following system of equations and determine the solution. X minus y equals 7, x plus 5y equals negative 5.
So to solve this system, what I'm going to do here is put these both into slope-intercept form. Okay, so again, here's my equation 1, here's my equation 2. Okay, I'm going to try to use that method of labeling as often as I can here. In equation 1, I'll bring the x over, so it'll be negative y is equal to negative x plus 7, and then I'll divide by that negative. And so y is going to equal positive x minus 7. And this is a good example of what I was talking about just a couple seconds ago here. So my y-intercept here is negative 7, so I'm going to come down to negative 7. There it is. And I'm going to use the slope, which is just a 1. Okay, the slope is 1, so 1 over 1. My rise is 1, my run is 1. And so I'm going to use that to find the next lattice point right there. And then I'm going to do it and find the next one. I'm going to keep following. And then I'm just going to throw these down here. And what this does is this gives me a whole bunch of points. Because, yeah, it's true that you only need 2 points to graph a line. But practically speaking, when you're drawing it with a pencil on a grid here, you need more than that, okay? Just 2 points here. I've seen people draw all sorts of lines, different lines through 2 points. They're sort of the same, but when you get away from those 2 points here, they can be quite different here. But if you got a whole bunch of points here, this actually becomes fairly hard to mess that up. The second equation here, we'll go down here. Okay, I will bring the x over, so 5y is equal to negative x minus 5. And then I'll divide by the 5 here, so y is equal to negative x over 5 minus 1. Okay, and so now my y-intercept here is negative 1, so there it is right there. And my slope is negative 1/5, so down 1 over 5. 1, 2, 3, 4, 5. And there it is. Notice that I've already highlighted that point. Okay? And now when I put this next line in here, I'm highlighting it again. So this point right here. Down 1, 1, then over 5. 1, 2, 3, 4, 5 right there. And that's that's a couple points here, 3 points here. That's really, I would like a couple more. So I'm going to start back at my y-intercept. I'm going to go up 1, back 5, up 1, back 5. And so here's my set of points. But I can already tell that that's my point of intersection. It's going to be the point 5 comma negative 2. Okay. Now the answer to this equation is the point 5 comma negative 2. Now, you got to be clear, everybody, and we're going to be jerks about this. This is not the answer. That is not the answer. Okay, this is the answer. If you don't have the parentheses there, you've just listed off two numbers and they have really no significance. But as soon as you put those parentheses around, this becomes an ordered pair. The first number refers to the x-coordinate. The second number refers to the y-coordinate. The parentheses are really, really important here. Now, let's just zoom in a little bit here. And now we're going to take this point here and we're going to check it just to make sure that it does in fact work, that I have read it off the graph correctly here. Okay? If I take equation 1, if I plug that in, 5 minus negative 2, what does that equal? Well, it does equal 7. There's equation 1. So I've taken that point, plugged it into equation 1. It is the same thing. It does equal 7. Equation 2, 5 plus 5 times negative 2. Well, 5 negative 2 is going to be negative 10. So 5 minus 10. Yes, negative 5. Good. So that point does satisfy both equations. It's the correct solution.
Example 2. Graph the following system of equations and determine the solution. X minus 2y equals 3, x plus y equals 0.
So for this question, we're going to solve the system here, this x minus 2y equals 3 and x plus y equals 0. Again, I'll label that equation 1, equation 2. And I'll do it like I've done the previous one here. I'm going to put these into slope-intercept form. So equation 1, I'd first of all move over the x. So negative 2y is going to equal negative x plus 3. Divide by the negative 2, so y is going to equal, well, that's going to be x over positive 2 minus 3 over 2. Okay? Now, that's not a fabulous couple of values there, but that's okay. So negative 3 over 2, that's like negative 1.5. That's right there. But my slope is 1 over 2, so I'm going to go up 1 over 2. So up 1 over 2, up 1 over 2, up 1 over 2. And I've got a handful of points here, but I can go the other way too. So I can go down 1, back 2. Whoops, sorry, down 1 is going to be down there, back 2. Down 1, backwards 2, down 1, backwards 2. And that gives me a whole lot of points here. Now, if you take a quick look here, notice that even when I graph it like this, notice that I am going through some lattice points here. Not on the y-axis, but on either side, okay? I'm going through those points right there. Now, hopefully, my second line will pass through one of those. So let's take a look at equation 2. And if I bring the x over, I get immediately y equals negative x. Okay, so the y-intercept is 0, the slope is negative 1. So here I start here. Negative 1 is down 1 over 1. Well, okay, I'm right there. Now, I am pretty sure that's the point that they're looking for. But I'm going to keep drawing because I want to draw that line here. So down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And when I go back here, I want to fill in the rest of it. So I'm going to go up 1, back 1, up 1, back 1, and so on. And so now I can connect those dots, and that seems pretty clear as the solution of this, which is the point 1 comma negative 1. Now, let's check and see. Here, let's zoom in just a little bit here. Let's see if that works. So let's take a look at equation 1. Okay, so if I plug 1 in, minus 2 times negative 1, well, negative 2 times negative 1 is positive 2. Well, there we go, 3. And there it is. There's the first equation. That one works. Equation 2, 1 plus negative 1, and that equals 0. Good. That is the correct solution. It satisfies both equations simultaneously.
Example 3. Graph the following system of equations and determine the solution. Y equals x minus 1, y equals 3 over 2x minus 3.
So once again, in this question, we're being asked to solve the following system by graphing. Okay, now I'm going to do this one a couple of different ways. Okay, I want you to get comfortable with the calculator as well. So we're gonna deal with that. But I'm going to do this by hand first, and then I'll use the calculator. And the reason why I'm going to jump on this right away is this one's actually set up really, really nicely here. They're both these equations right now, equation 1 and equation 2, okay, are both set up nicely for me in slope-intercept form. So let's take a quick look at that first one there. I know that my y-intercept is -1, okay, and my slope is 1. And as a slope of 1, I interpret that to mean the rise is 1, the run is 1. So up 1 over 1, there's my next point, up 1 over 1, up 1 over 1, up 1 over 1, and we keep going until I fill those all in. Then I go back here, and if I want to go backwards, I'll go down 1, back 1, down 1, back 1, and I keep doing that. And then I've got enough points that I can draw that line through, and I know that I've hit all the major lattice points. The next one here had a y-intercept of -3, so 1, 2, 3, and the slope was 3/2. So from there, okay, my rise is +3, so I'm going to go up 3, 1, 2, 3, over 2, 1, 2. Then I'm going to go up 3, 1, 2, 3, over 2, 1, 2, and there it is. I'd already hit that point, and I'm hitting it again. So right there. So I know that's the solution to the system. But I'm going to draw the other point here. So up 3, 1, 2, 3, over 2, 1, 2. There it is. And then I'm even going to go backwards because I'm going to try to fill this out as much as I can. So from the y-intercept, I'm going to go down 3, 1, 2, 3. But if I go down 3, I got to go backward 2, 1, 2. And now if I connect those dots, okay, I am pretty darn sure the answer to this is 1, 2, 3, 4, comma, 1, 2, 3. Okay, now I will go through and we'll double check this. Okay, so we're going to just zoom in just a little bit so we can really clear on that system there. Here's equation 1. So is 3 equal to 4 minus 1? Well, yes, it is. Okay, so it satisfies, that point satisfies the first equation. Equation 2. Is 3 equal to 3/2 of 4 minus 3? Okay, well, let's just think about this. 3/2 of 4. Well, I can cancel the 2 out of that. So 4 divided by 2 is 2. 3 times 2 is 6. Minus 3 is 3. So yeah, it does satisfy that equation there. Good. So this is the solution here. Now, I am going to go through, though, and I want to talk about how you do this on your calculator. So, sorry, maybe I should go back to this page, this screen here. So you turn on your calculator. Here you go. We go to y equals. So in the first one, I'm going to enter my first equation. So y equals x minus 1. So, and again, just so that we know where our variable button is, this is the variable button typically you want to use, right next to the alpha button. There's my x. Okay, so there's my screen there, x plus, sorry, I forgot what the equation was, x minus 1, my first equation. And then the next one was 3 divided by 2x, what was it again, minus 3. Okay, so those are my two equations there in this system. I would press zoom number 6. Okay, zoom number 6 takes me to the standard zoom settings. The reason I would do it like this is because if I've played with the calculator before, if I've had to alter things a little bit, my window settings are off. If I ever get kind of turned around and I need to kind of go back to just a standard window setting, so the brand new question, zoom number 6 is the quickest way to do it. I don't have to play with the window settings myself. It's just done. Okay, so there's the second line. So now let's talk about how you find the point of intersection again. Okay, we press second, trace, to access the calc menu right there. And once we do that, we're into this screen right here, and the option that we want is intersect. So number 5. Number 5 basically drops the cursor on the first equation that it finds, so y1. Is that the first equation? Press enter to say yes. Is this the second equation? Press enter to say yes. Is it okay if it guesses 0, -3? Yeah, sure. Guess, would knock yourself out. Just press enter, and it takes you to the point 4, 3. Look at that. We got it right.
Example 4. Graph the following system of equations and determine the solution. Y equals 2/3 x minus 1, x plus y equals 4.
Okay, here's another question. Same thing, just here's a system of equations. We're going to determine the solution here. Again, I'm going to label this equation 1. This will be equation 2. So the first one is 2/3 x minus 1. That's already in slope-intercept form. I love that. The second one here isn't. So I'm going to put it in slope-intercept form. Again, this isn't the only method that you can use, but it does have some nice benefits to it. So I'm going to just keep using it here. So I'm going to bring over the x. So y is equal to negative x plus 4. Okay, now let's graph these guys here. So the first one here has got a y-intercept of negative 1 and a slope of 2/3, meaning I start here at the y-intercept. I'm going to go up 2, 1, 2, over 3, 1, 2, 3. Up 2, 1, 2, over 3, 1, 2, 3. I've hit the edge of the graph, so I'm going to go back to my y-intercept and I'm going to go backwards. So now I got to go down 2, left 3, down 2, left 3. And now I can connect the dots. It's not a perfect line, but it's pretty good. The next one here has got a y-intercept of positive 4. So here 1, 2, 3, 1, 2, 3, 4 right there. And my slope is negative 1, so down 1 over 1, down 1 over 1, down 1 over 1, and there it is. Okay, there's my solution right there, down 1 over 1, down 1 over 1, down 1 over 1. And then again, I would go back to my y-intercept and go the other way. And now I can connect those, I can connect those dots right there. Ugh. Oh, look at that, I missed. So I know what you do, you make the dot bigger. There you go, see, I hit it. There you go. I got those points. But actually, that's right there. Right there is a good reason why it's a good idea to use the slope-intercept form, because the lattice points, okay, are very often the solutions. Now, they're not always the solutions, but often they are, and you see it way more clearly if you identify them all. If you identify all the lattice points that you hit when you're graphing the line there. Anyway, it's just a suggestion here. But it looks really a lot like my solution here is the 0.31. Okay, let's go. Again, we'll zoom in just a little bit here. And we'll take that equation 1. We're just going to check it. So does 1 equal 2/3 of 3 minus 1? Well, 2/3 of 3 is 2 minus 1 is 1. So yep, that works. 2. If we take 3 and we add 1, do we get 4? Well, yeah, we clearly do. Okay, now, once again, I want to show you how to use your calculator, okay? Because you really do got to get familiar with the technology here. So we go back to our y equals, and it's 2 divided by 3x. Okay, and again, I'll just remind you, remember to use this button right here, right next to the apps button. That's your x. Okay, minus 1. Then what was the other equation here? Brought that x over, so negative x, and again, plus 4. Remember to use the negative button here, not subtraction, when you're identifying that x is negative. Okay, they mean different things. Well, they're really similar, but the calculator sees those as different. And if you make a mistake, if you put negative here, you'll get this syntax error, and man, it's hard to see. Man, is it ever hard to see that. Anyway, so there we go. Just press graph. My Windows settings don't need to change here. There we go. And there we go. And so now, second trace. Okay, I choose number 5. It's intersect. Am I on the first curve? Yep. Did I jump to the second curve? Yep. Can I guess? Yeah. Guess whatever you want. And there it is, the 0.31. Now, another thing that we can do while we're here, might as well mention this, is you can actually go and investigate your table of values here. If you press second graph, it takes you to a table of values here. And what we're looking for here is the x-coordinate where the two y-coordinates are identical, and that's going to be the 0.31 and 31 here. So you can actually tell from the table of values what the solution is as well. Either way, both work.
Example 5. Verify that the ordered pair 3, 2 satisfies a system of equations 4x minus y equals 10, negative 2x plus y equals negative 4.
So in this question, we're being asked to verify that the ordered pair 3, 2 satisfies this system of equations. Okay, again, it becomes really clear with a question like this. Again, just being really honest with everybody here. A question like this really helps us as teachers to identify whether or not you really understand what this is. Because I've had a lot of students that yeah, if you ask them kind of point blank about a point, yeah, they get the x and the y here. But they don't actually make the connection that the x and the y we're referring to on the coordinate plane actually mean the x and the y that we're seeing in these equations. For some reason, they're not connecting that. So a question like this, as straightforward as it is, can sometimes be really confusing to some people because they're not making that connection. So here, what we're going to do here is I'm going to label these equations 1 and 2 here. So in equation 1, I'm just going to verify that that point works just by plugging it in, by replacing it. So 4, this is 4x minus y. Well, x is 3, so 4 times 3 minus y, well, y is 2, equals 10. Is that true? 12 minus 2 is 10? Yes. So it satisfies the first equation. Good. Let's take a look at the second equation. Okay, negative 2 times x, well, x is 3, plus y, well, y is 2. Does that equal negative 4? Well, that's negative 6 plus 2 equals negative 4. Yes, it does. And so because I've been able to verify that the left side and the right side of both these equations are the same, when you substitute those coordinates in to those equations, those variables there, I've shown that that point is the solution to that little system.
Example 6. For what values of m and n is the point 2, 5 the solution to this linear system? mx plus y equals 19, nx minus 2y equals negative 6.
Okay, this question right here, it looks maybe a little bit more complicated than it really is. This question right here, for what values of m and n is 2, 5 the solution to this linear system? Okay, let's take a quick look at this system here. In fact, let's zoom in just a little bit here. So mx plus y equals 19, nx minus 2y is equal to negative 6. Now, in a very similar way to the previous question, a question like this is really, really testing. Do you understand what that is? And when we say a solution, do you understand what that means? This is the x coordinate, this is the y coordinate. We know that because it's an ordered pair. Well, what x am I referring to? These x's. So what this means here, okay, is equation 1 is going to become m times 2, y is 5, so plus 5 is equal to 19. Well, now immediately, look at this. This is an equation with a single variable in it. Well, I can figure out what m is. Subtract 5 from both sides to get 2m is equal to 14. Well, m is equal to 7. Okay, well, that's interesting. The first equation, by plugging in that point, just almost immediately spits out that value there. Let's take a look at equation 2. Again, it's the same point, so it solves this equation as well. It satisfies this equation, so it's n times, well, x is 2, minus 2 times y is 5 equals negative 6. And again, immediately I get an equation that's only got one variable in it. So negative 2 times 5 is negative 10. So this is 2n minus 10 equals negative 6. Add 10 to both sides. 2n is equal to 4. N is equal to 2. And there you go. So the two solutions that we were looking for were 7 and 2. Now in this case, I don't need to write my answer as an ordered pair, okay? Because that would actually get a little bit confusing, because it would, if I put this as an ordered pair, it would almost immediately imply x and y, okay, particularly in the context here. So I do want to keep this clear that this is a different variable separate from the solution. These are parameters, if you will, and not variables.
Example 7. Jerome purchased small and large multi-packs of yogurt. Each small multi-pack contains 4 yogurt cups and each large multi-pack contains 12 yogurt cups. Jerome purchased 9 multi-packs for a total of 60 yogurt cups.
Okay, so if S is the number of small multi-packs purchased, And L is the number of large multi-packs purchased. Now the wording's a little odd here, but the linear system that models this situation is going to be this. S plus L equals 9, and 4S plus 12L is equal to 60. So let's maybe zoom in just a little bit on that. Whoops, wrong direction. There we go. So there's our system here. Now, we're using S and L here because it matches the word problem, okay? But when we graph it, we really need to make a choice here. Which one of those is going to be the dependent variable? Which is going to be the independent variable? Which one is X? Which one's Y? So the hint in this case here is the grid that we're given. So the number of small multi-packs, S, okay, is in the place of my X variable, and this one's in the place of my Y. Okay, so now that's kind of how I want to think about this. So I'm going to kind of rewrite this. Now, again, this is equation 1, this is equation 2, and I'm going to solve this the way we've done the last several here. So, but I'm going to make this x plus y is equal to 9, and I'll make this one here 4x plus 12y is equal to 60. And so now equation 1, I'll bring that over, so y is equal to negative x plus 9. Now I got to bear in mind that for right now, I've made a little transition here, right? I'm going to say, just to help me out here, kind of over on the side here, I'm going to let S be X, and I'm going to let Y be L. Okay, so just so I can graph it, and I'll fix that in a bit here. Equation 2, well, okay, equation 2, I got to bring that over first, so 12y is equal to negative 4x plus 60. And when you divide here, y is going to equal, what is that, negative 1/3 x plus 5. Okay, so now I can graph this here. The first line here has got a y-intercept of 9. Okay, so y-intercept of 9, that puts us way up here. And a slope of negative 1. Okay, well, that's easy enough to graph here, so it's going to be down 1 over 1. And so I'm going to get, my line, I should say, is going to hit all of these lattice points. Oops, I don't know why I just dropped the pencil, but anyway, I can connect those dots nice and easy. This one right here has got a y-intercept of positive 5. That's right here. And it's got a slope of negative 1/3, so down 1 over 3. Down 1 over 3, and there it is. That's the point that I want. Down 1 over 3, and away we go. So now I can connect the dots. But I can see right there, there is my point of intersection there. And that's at the point 12, okay, comma 3. Now, let's just, before we move through and answer this question, let's just make sure that that works. Okay, so equation 1. Now, remember how I did this. This is supposed to be S, and this is L. Okay, so let's take a look at equation 1 up here. S plus L is equal to... oh my gosh. Oh, okay. Actually, you know what? You know what? I'm going to use this as an opportunity. This is a great learning moment here. Okay, I screwed this up. Not a huge screw up, but enough that I got to go through and do this again. There was probably a whole bunch of you out there going, wait! And you'd be right here. This is a good opportunity. I screwed this up here. The reason why I screwed this up is because I wasn't very careful with what I was reading here. Let's go back and graph this again. This is actually really good here. Okay, so the y-intercept here for equation 1 was 9. That is the point right here. The slope is negative 1, so that's down 1 over 1. But look at the scale here. This is what I screwed up. The scale here, these are going up by 2's. So down 1 over 1 puts me here. Down 1 over 1. Down 1 over 1, down 1 over 1. You got to pay very close attention to the scale, and I did not do that when I started. Okay, so now when I connect those dots there, that's the line that I'm getting. Okay, now the next one here, negative 1/3 x plus 5. Well, again, 5 is pretty easy to identify. That's right here. The scale, though, is now 1 down over 3. So that's going to be 1 down over 3 is 1, 2, 3. 1 down over 3, 1, 2, 3. So there's my solution. 1 down over 3, 1, 2, 3. 1 down over 3, 1, 2, 3. 1 down over 3, 1, 2, 3. Now, I'm only going to go out to there because it really doesn't make sense to talk about these lines once they dip into the negative, particularly because of what we're talking about here. Actually, this doesn't even make sense to talk about it in terms of the fractions, about connecting the lines here, but we use this to help us solve the system, right? So we're making that allowance here. But anyway, so here's my solution, and now it looks like 2, 4, 6, comma 3. Now that's a much more reasonable solution. And now let's go through and check these here. So this is, again, this is S, this is L. So let's look at the original equation here. So 6 plus 3, does that equal 9? Yes. Equation 2, does 4 times 6 plus 12 times 3, what does that equal? Okay, well, 4 times 6 is 24. 12 times 3 is 36. That gets you 60. So yes, turns out that is the solution to the system. So we should get 6 small, oops, can't see that, 6 small and 3 large.
Example 8. Annika purchased sleeves and boxes of golf balls. Each sleeve contained 3 golf balls and each box contained 12 golf balls. Annika purchased 7 packages for a total of 48 golf balls.
Okay, so if we allow S to be the number of sleeves purchased and B be the number of boxes purchased, then this is the system that we're going to get here. Now again, the wording's a little awkward here, but here's the system that we're going to get. And I'll zoom in just a little bit on, whoops, wrong direction, on that right here. So here we go. And similar to the previous question, I now, if I'm going to graph this, I now need to make a choice which of these is going to correspond to X, which is going to correspond to Y. Now, when you're given a graph like this, you can kind of use this to help you out here. The number of sleeves is along the X-axis, the number of boxes is along the Y here. So the connection's been made right now. We're going to let S be X and we're going to let B be Y here. So here's equation 1. This is equation 2. And so this is really going to be X plus Y is equal to 7. And this will become 3X plus 12Y is equal to 48. Now, to graph these, okay, here's equation 1. To graph these, I'll just isolate the Y. So in the first equation, it'll be negative X plus 7. Okay. In the second equation, I'll do a little bit more work. It's going to be 12y is equal to negative 3x plus 48. And when you divide by 12, we're going to get negative 1/4 x plus 4. So let's graph that first one there. Here we go. So negative x plus 7. So the y-intercept is 7. I'm going to be careful now about the scale because I messed that up on the last one. I don't want to do it again. So these are going up by 1, so here's my 7. My slope is negative 1. But again, down here, along the x-axis, the scale is going up by 2's. So my slope here at negative 1 is going to look like this. Down 1 over 1, 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 down 1 over 1. There we go. So now I'm going to connect the dots here. Okay. Now I go to my next one, y-intercept of 4, and then it's got a slope of negative 1/4, so down 1 over 4. That's 1, 2, and that's right there on that lattice point. And there's my solution. Down 1 over 4, down 1 over 4, down 1 over 4. But again, I got to connect those dots. Again, though, just to be fair, the lines themselves are not 100% accurate because the data here would be discrete, and this is implying continuous data. But in this case here, that's totally okay because we're just looking for the solution to the system. And in this case, it looks like the answer is 4, 3. Okay, where this is my sleeves, this is my boxes, but let's check it. Let's check our answer here. So let's take a look at equation 1 here. 4 plus 3 equals 7. Is that true? Yes, it is. Equation 2 here. 3 times 4 plus 12 times 3. Okay, well 3 times 4 is 12. 12 times 3 is 30. Really what this is like 1 12 plus 3 12s is 4 12s. That's 48. And that's what we're seeing in the original questioner. So yeah, that's true. So the answer is we purchased 4 sleeves, or sorry, Annika purchased 4 sleeves and 3 boxes. There you go. That's the solution that we're looking for. With these word problems here, it's important to interpret your answer. Like there should be, not only should you get a point here, just like we did in the previous question here as well. Not only do you want to get a point, but you want to interpret your answer here, because oftentimes, like when you ask a question like how many did she purchase of each, if you just say 4th comma 3, well that doesn't make any sense. You need to interpret the answer. However, in other questions, when we're asked, for example, to solve the system, like we did, for example, back here, question 3, it's just enough to write the answer as a point. And so there we go. Remember what a system is. A system is multiple equations that are going to be true simultaneously. We're looking for the point of intersection between those two, that point that satisfies both equations when you plug that in. And we can do that graphically in one of two ways. We can either do it by hand, or we can use the calculator as I've shown you a couple of times.